So now we're all put together here in this little box. Probably need to paint it to make it look prettier, but I have a little glass covering and glued on. So it's we have ourselves the actual frequency counter, RPM meter, period counter. It's all in here. It has input signals for the various components and switches to turn it on from period counter to frequency counter. A little calibration for the 0.5 hertz signal, which is here. It can be visualized through there. And then this is the anemometer interface, so that we could produce the period from the anemometer. The period comes to this big red wire that comes out of the inverted signal from the Hall sensor, and that goes into the clocking signal that connects to this white wire here, which is the clock of the CD4017. That CD4017 is activated by the period. The period is counted by an 8-bit binary counter that at the end of the that happens during the second phase of this cycle. At the end of that phase, the binary value in the 8-bit binary up counter gets transferred to a second 8-bit binary counter, but this is a down counter. The down counter is clocked in at 18 kilohertz by this clock right here. And it's clocked to count down. Every time it hits 0, it sends out a signal through that little blue wire right there. That signal goes through the white wire here and gets the input signal of our count. The period of that count is gated by the red wire there, which goes around the back there and is connected to this 555 timer in bistable mode. And so that bistable mode goes on after the period count is done. And what that does is it activates the down count at 18 kilohertz. And also it sets off a counter to 6,000. So it counts up to 6,000 at the same time as it counts the period count down over and over and over again at the same rate, which is 18 kilohertz. That green, that other 555 timer right there, that's that green signal. And you'll see that go on when it goes into the second phase, into the third phase. There it goes, and there it went. And do it again. And every time that happens, we get a reading, which is approximately every 1/3 of a second. So every other rotation, we get a reading. And as you can see, all right, so when this is rotated, if we rotate it faster, and that reading is miles per hour of the wind. That's with the fudge factor and the calculations for rotation based on the full rotation. The radius of this is 7.5 inches. So 7.5 inches, the amount of travel that this does is 2 times pi times that radius of 7.5 inches. And that's the number of inches. We convert that to feet and miles. And that gives us our value of miles per hour. So this part of the circuit is working well, and it's complete finally. I'm gonna make a video with a full schematic after it's all done, and I have this one packaged and working nicely without these long wires connecting everything. So stay tuned. The vlog continues, but it'll be done soon. We'll get on to a different thing. But thanks for watching.